By the end of the 21st century, humanity is becoming desperate. Decades of heatwaves and droughts have led to unusually poor habitats. While the warming oceans yield flare fish each year, in the tropical zones millions suffer from famine, and resource wars have made millions more flee to the north. As things quickly get worse, in an act of desperation, the world's governments decided to enact an emergency plan. It is far from the certain that a grim scenario like this will play out, but the human rates the essentially adverse climate change make it from the impossible. So in the near future, it might become necessary to try something radical to slow down rapid climate change. Geoengineering environments that are so massive in scale then might undo certain of human behavior or make everything much worse. What is geoengineering? Is it really an option, and what if it goes wrong? Geoengineering methods vary from fantastic ones like constructing giant light cells in space to seeding clouds with salt or wilder ones like fertilizing the oceans with iron to speed up the growth of the trillions of algae cells. In this video, we will focus on an intervention we could see during our lifetimes. Stratospheric auroral injection, a clunky term. It means spraying stuff very high up in the atmosphere to keep the sun away. Keeping the sun away. CO2 does not heat up the planet on its own. Almost all the energy on the earth comes from the sun in the form of electromagnetic radiation. About 71% of this energy is absorbed by the earth's surface. In the form of atmosphere, this absorbed energy is emitted again as infrared radiation, and CO2 is able to trap this infrared radiation and keep it in the atmosphere for a while. You can compare this effect with struggling under a blanket in the morning. Even in a really cold room, your body emits infrared radiation, and the air between your body and blanket traps it and creates a warm and comfy feeling. So one way to cool down the planet would be the prevalent energy from getting trapped under your planet blanket, which is already happening naturally. About 29% of the solar radiation hitting Earth is reflected back to space by bright surfaces like ice, deserts, snow or clouds. More reflection, less energy, less warming. We can look at nature for inspiration. Significantly in 1991, Mount Pinatubo eruption, the second largest volcanic eruption of the 20th century, aside from massive devastation and almost 900 dead. Scientists noted its strong impact on the global climate. The explosion ejected millions of tons of particles and gas as high as the stratosphere, which hung around there for a while. The stuff that interesting in geoengineering is sulfur dioxide, a nasty smelling and invisible gas. High in the atmosphere, it produced a haze of sulfuric acid floods and mixed with water and created giant vessels. The wells retained the sunlight, reaching Earth's surface by roughly 1%. Global average temperatures dropped by 0.5 degrees centigrade. It looks 3 years until this cooling effect had stopped. Humans could imitate this process by injecting sulfur particles directly into the stratosphere. According to some scientists, this might be surprisingly easy to do, and you don't even need a lot of new technology for it. According to one study, it might also be pretty cheap compared with the cost of rapid climate change. A small fleet of specialized air flaps could ascend all year and distribute alcohols from airing the square plant for a decade was separated around the world. Projections assume that injecting between 5 and 8 megatons of material per year would reflect enough sunlight to slow down or even stop global warming, giving us precious time to transition away from fossil fuels. Unfortunately, there might be a few unhappy side effects. There are a number of potential issues with aerosol ejections. Rainfall patterns could change, which could negatively affect agriculture and cause famine. Billions of people could be affected in the worst case. Also, after the 1991 Mount Punatawa eruption, the acid or water vessels not only cooled down the surface, they also heated up the stratosphere. As it turns out, acid is bad for the ozone layer, and the ozone hole over Antarctica was the largest it even has been. Injecting sulfur particles over decades could have a similar effect. Scientists have already suggested using a combination of different minerals that might have much less harmful effects on the ozone layer. But more research and experiments need to be done to make sure if this could hurt. But even if it don't damage the ozone layer, there are other risks. Politicians and industry might use the cooling effect as an excuse to delay the switch to a carbon-neutral economy. Even if geoengineering slows down global warming, humanity is still adding extra CO2 to the atmosphere. More CO2 in the air means that the oceans absorb more CO2, which makes them more acidic. This is already beginning to do badly to huge ecosystems like coral reefs. And the longer this continues, the more severe the effects will be. But it gets worse when we start pumping particles into the atmosphere on a massive scale. We might be forced to do so for a long time, or we could risk a termination shock. What that means, if humanity continues to enrich the atmosphere with CO2, but at the same time prevents the planet from the heating up by blocking solar radiation, we're sitting on a time bomb. Once we stop geoengineering, the neutral cycle would take over again and Earth would heat up. After a few decades, keeping the planet artificially cold while still releasing massive amounts of CO2, it would heat up much quicker. An increase in temperature that would take 50 years today could happen in just 10 years. Such a temperature shock in such a short time would disrupt every major systems on Earth so much it would be impossible to adapt in time. The worst case scenario could be demonic famines and rapid destruction of ecosystems. Humanity might survive, but the survivors would inhabit an unfamiliar and hostile world. The best case scenario is that once the world has fully understood the essential danger of rapid climate change, geoengineering can buy us a crucial decade or two. Time to transition our economies and maybe even pull CO2 out of the atmosphere, maybe the technologies that we will discuss in the future video. Conclusion: geoengineering is a scary concept. It's not a solution to climate change, and it might even be a welcome excuse for the fossil fuel industry to delay the end of the fossil fuel age. Over the last few decades, geoengineering has been a controversial that stops many scientists from doing the experiments necessary to understand it better. But blankly impossible geoengineering is short-sighted. The sad truth is that we are already running a geoengineering experiment. We are testing how fast the world changes if we add 40 billion tons of CO2 each year. The experiment is about to get really exciting. Hopefully, we never have to use geoengineering, but we need to in the future. We better have done the science, so we better be prepared for a panicking humanity. Might accidentally press the self-destruct button. Click. You probably won't have to do any of that yourself, but who knows, better brush up.